Hello YouTube, and in one of my videos titled Leaky Lithium, some batteries leaked and they were lithium. Yeah, anyway, these batteries were in a camera and they got wet and they've stopped working, and you can see the corrosion on them. So what I intend to do is try and clean the corrosion up, see if I can actually recover and reuse these batteries. If I stick them on a charger right now, they don't charge. So hopefully it's just crud on the connectors, so we'll give these a clean and see if we can hopefully bring them back. Right, I've propped the phone up, I think, so I can have two hands. I think this works. So what I intend to do is scrape away the crud as much as possible with a screwdriver. And then once that's done, I'm just going to use normal window cleaner on a bit of tissue, which I have here. So, a little bit of tissue, spray some window cleaner on it, and this is just normal household window cleaner, and they're going to use that to clean the top of the battery. So a little bit of elbow grease, window cleaner, and a little bit of scraping, and already that's looking better. So I'm going to do this to all the batteries. Just go along. Even now you can see just it sort of softened it up. You can just push it off almost, the rust. And there you go. That end's cleaned up. So I'm going to do all four of these and then we'll see if they charge. So all four batteries have been cleaned, and you can see this one's the most scratched. So a little bit scratched on top, but you know, that's only superficial. A bit scratched on the bottom, but all the rust is now off. So it should hopefully make a good contact. One of these was actually quite bad at the bottom. I think it was that one. You can see it's all a bit near still. There we go. So they're nice and shiny. All we've got to do now is check the voltage on them. So this battery here measures 1.6 volts, which is low for a lithium cell, but we should just be able to put this on a charger and charge it. And that cell is now on a charger and is charging. So this one, I think we can recover. All the other cells are like this. So this one is reading 111 millivolts. So that's 0.1 of a volt, very low. Now it is in the right polarity, so it hasn't been reverse polarityed. So we should be able to recover this if we charge up at a very, very low current. If the polarity had been reversed, the cell will be dead because you get copper migration between the plates. But because it's still positive potential, we should be able to charge this up at, say, so this is a 650 milliamp hour cell. If you say charge up at 10 milliamps until the voltage reads about 2 or 3 volts, we should be able to recover it. So I want to connect it to a power supply. So I've got these little DuPont leads with these ends on them. So I can connect it to a power supply. So there's a little hole in the top here. So one end can poke through the little hole. The other end I've just held on with a magnet. And you can spot the deliberate mistake. I've got the red and the black and the black and the red. I shall swap them over. Excuse the extremely poor lighting and the sound of a rustling bag, but I'm currently laying on the floor. So I've set the voltage to 3 volts, and the current I shall set down a bit to, that'll do, 16 milliamps. Battery's connected, polarity is correct, and we'll see if it explodes, shall we? Yeah. Right, so the current limit's been hit and the voltage is rising. There's no power going to the battery because the current is so low, so we shouldn't have any heat build-up at all. And when it gets to about 3 volts or so, we should be able to put it on a normal charger and see what happens. But yeah, the voltage is rising. This is a good sign. So it's been about 20 minutes and the voltage has gone up to 1.9 and the current's gone up as well, which I don't know why because I set it at 16. Oh, it's only gone up a little bit. So that looks like that has started to recover. So if we increase the current slightly, what happens? Take it up, say 15 milliamps. Still no real explosion. The voltage should go up fairly quickly and then stabilise, because the lowest end of the battery is the least amount of power. So as you put more power in, it will get to that point quickly, and then on the higher voltage bit, more power is needed to lift the voltage up. So the voltage going up should slow down, if that makes sense. Right, so we've just reached 2.7 volts, so I'm going to turn it off now. And we're going to let the battery sit for a while, a few minutes, and then we'll see what the voltage is, if it's retained that voltage, and then I'll put it on a normal lithium charger. Right, so the voltage is dropping slightly. In fact, it's dropping quite quickly. I'll put this on the charger now so it still recognises it as a battery and charges it. And we just have to see what happens. Right, so it's on the charger and charging. And no smoke, no fire. See what happens. So what I'll do, I'll repeat this process for all of the batteries that I've got. And then I'll do another video where I'll do a capacity check on them all. So we can see if any have recovered and what, if any are recovered, what their capacities are and how much damage has been done. So I've got these 4 and I've got another 4 to do, so that's 8 in total, which are dead. So hopefully out of the 8 dead ones, we'll have at least one good one. Maybe. Right, for now, so I'd save you from the time just watching batteries charging, which would be quite boring. I shall see you in another video where I'll measure the capacities. That'll be the next video to go up. So see you later. Bye.